Alright, welcome back to another Swift Coding episode. Today we're going to be learning about the signs and symbols for different electrical components. Last lesson we learned about electrons and protons and what they have to do with power and electricity. So let's get right into it. The first component, the most important component, is the power supply sign. And the power supply sign kind of looks like this. And with the wire going around, just a basic circuit. Last lesson we learned about anode and cathode. Anode being the long side, cathode being the short side, cathode being a negative, and anode being the positive. Here, the power supply sign looks like this, the long side being anode, short side being cathode. Usually we'll see it like this, with components such as resistors and LEDs and diodes. Sometimes, whether you're solving a problem or not, they won't give you the voltage, but in this case we can have 20V, and basically what this is saying is current coming from the positive side down all the way through to the negative side, 20 volts. The next component we are gonna see is a resistor, the most common electrical component. So let's put a little thing here. We have plus, minus, and let's give it 20 volts again. Last lesson we learnt about Ohm's law, which is the relation between resistance, current, and voltage. So how we do it, you might have seen this, you might have noticed this last episode. It looks like a little squiggle. And again, depending on whether you're solving a problem or not, it will not give you how much resistance, and resistance is measured in ohms. Kind of like why they call it Ohm's law, because it's the relation between resistance and other things. So we can give this 10 ohms. Ohms uses the omega symbol, such as 20 uses V for voltage. We can calculate this, and how you'll see it if you're solving a question is you might see it like this. You might see a point here, and it'll give you I or V or R, whatever they want you to solve. For here, the current, we want to know the current for this circuit. If I equals voltage divided by resistance, we can write that as I0 equals V over R, or I0 equals 20 over, and then the total resistance of the entire circuit. So I0, which, since there aren't really any other parallel resistors or like any other exceptions, we have 10, and just like last time, we get 2 amps. And basically what a resistor does is it slows down voltage. It lowers the amount of voltage going to another electrical component. And if we see a resistor looking like this, then we call it series, but we'll learn more about that in another lesson, series in parallel. The next one we're going to learn about is capacitors. And have you ever thought how things are wireless, how things can be taken out of charge and can be kept there? Sort of like a battery, but except capacitors are smaller, don't have the lifetime of a battery, and we see it like this. Capacitors are probably the most complex circuit component we see. It is measured in farads, but farads is extremely big, so you might see it as millifarads. And how capacitors work is current goes through into this electrode, but you might think it just zaps No, there's a lot more math and a lot more things that are actually going on before electrons build up and zap into the rest of the circuit. So how this actually works is oxygen atoms, or just little anything atoms, hydrogen atoms, anything, are ionized. And what this means is, say we have chloride, Cl with the minus is an ion. We have a few shells. This is not realistic, by the way. The valence shell, the outer shell, might lose an electron. And when it loses an electron, it does this to, say there were like 8 electrons, and it loses. Let's say there were 9 electrons, but it loses one to become more stable. This gives it a negative atom charge and gives it electrostatic attraction, say if it was in a lattice. So it loses an electron to become more stable. And another place where we see this is we have sodium, which if it is an ion, it becomes positively charged. It's a positively charged ion. It loses. I think I've made a mistake. Chloride gains an electron. It gains an electron to become negative, and sodium loses an electron to become positive. Same way, we have a shell. It loses an electron to become more stable. And sodium chloride, you've probably heard of it before, and that's because it's table salt. You put them together, you get table salt crystals, little lattices of carbon. So, it's like that, but except we get oxygen atoms. And since electrons are negatively charged, electrons build up here, and to maximize charge, you'll usually see a diode here, and I'll show you a diode after this. Oxygen atoms become ionized because more electrons, they're becoming negatively ionized because more electrons are going through the electrode and they're building up. Oxygen atoms gain electrons until most of the atoms around it have become negatively ionized and provide a stable electron bolt through to the other side, and then we can have resistors and second battery and stuff like that. And capacitors are extremely common. Now we go on to the diode. It's really simple once you understand it. A diode, it doesn't have a unit because there's only one type of diode. No, not type of diode. There's only one diode you can get. There's no control variable. A diode in the middle of a wire looks like that. Well, it can only be in the middle of a wire. What it does is it makes it so that if, say, we have electrons going through, obviously, since electrons are negatively charged, you might get the occasional bounce back. It repels, this can repel the other one back. But since there's a diode, electrons won't be repelling each other back. And it basically rectifies a wire so that power cannot go back through it, but it can go forward through it. So that's what a diode is. We also have the diode that we saw last lesson. We have an LED diode, light emitting diode. It goes through gallium phosphate, emits light. Okay, that's it for this lesson. We've learnt about resistors, capacitors, and diodes, and LED diode, which is pretty simple. I'll see you in the next lesson.